Okay, here we go. Unit 6, Lesson 3. Let's analyze transformations that produce congruent and similar figures. 3.1, why is it a dilation? So point B was transformed using the coordinate rule xy to 3x, 3y. Okay, that's given to you. Number 1, add these auxiliary points and lines to create two right triangles. Label the origin P. Okay, there's P. Plot points M, 2, 0. There's M. And N, 6, 0. Draw segments PB prime. Okay. PB prime. MB and NB prime. Okay. Got it. Number 1's done. Okay. How do triangles PMB, right here, just shading it in orange here, and PNB prime, so the big ones, are the points of the big triangle. So how does this orange little guy compare to this bigger one right here? Well, I already know, but I'll show you my thinking here. Switch colors so it doesn't get all too crazy. All right, we have a parallel line, or a set of parallel lines, because we're using a coordinate plane. So these two lines are parallel. Then we got a transversal cutting across two parallel lines. So a line cutting across two parallel lines is known as a transversal. So PB prime is a transversal across MB and NB prime. So that's what I was just saying. So that's a transversal cutting across these two parallel lines, meaning that angle is congruent to that angle. And you also have the right angles. So I have what I need to make my claim. How do triangles, the little orange one and the big P and B prime, compare? Well, they are similar. How do I know? We got a pair of congruent angles and another pair of congruent angles. I know because there are two pairs of congruent angles, and by the angle triangle similarity theorem, I know the two triangles are similar. What must be true about the ratio of PB to PB prime? So they're asking us this one compared to this one. There's a couple ways you could go about that. So it's PB compared to PB prime. Well, Since x and y were both multiplied by 3, your ratio is going to be 1 to 3. So PB to PB prime is 1 to 3. That's the ratio. Now, how could you confirm that? Well, here's 2, here's 3, right? PB squared will equal 2 squared plus 3 squared. Pythagorean theorem, right? 4 plus 9. So PB squared will equal 13. So PB will equal the square root of 13. So this is the square root of 13. All right. Let's look at Pn. Pn is 6. NB prime is 9. So PB prime squared will equal 6 squared plus 9 squared. 36 plus 81. $110, 117. PB prime squared will equal 117, so you square root both sides. So you end up getting PB prime equals the square root of 117. So this equals the square root of 117. Now, I know that's not really helping you much, but check this out. Second x squared 13 is 3.6. Second x squared 117 is 10.8. There you go. 1 to 3. And that's because x and y were both multiplied by 3. Tough problem, not too hard though. All right, number 2, congruent, similar, or neither. Match each image to its rule, then for each rule, decide whether it takes the original figure to a congruent figure, a similar figure, or neither. Explain or show your reasoning. Okay, let's look for number 1. XY goes to x over 2, y over 2. That means it's going to be half as big, right? That looks like this one. Let's just double check. 6, 4, 3, 2. Yep, that's half. 6, 8 should be 3, 4. Yep. And 8, 4 should be 4, 2. Yes. So this is D. And similar. It's a dilation. Origin is the center. Scale factor equals 1/2. F to F prime. Okay, XY becomes Y negative X. Okay, that one's tricky. X, this one's easy. XY becomes X minus 4, Y minus 3. So that looks like this one. 1, 2, 3, 4. 1, 2, 3. Yep. This one is C, congruent. And it's a translation. Left 4, down 3. Okay, so C and D are done. So C and D are done. So now you just got to figure out A and B. Okay, so let's see. I'm thinking that this one is B because these are not the same size. Let's just triple check. We start at F. -2, 1. Looks like it goes to 4, 1. Let me see here. I think this is A right here. So it's D, A, B, C. Let's just double check. We got 1, comma 1. We got 3.5, comma 1. 3.5, comma 2, and 1, 2. Over here we have 2, negative 3.5, and we have 2, negative 1, and we have 1, negative 3.5, and 1, negative 1. Okay? So yeah. 1, 1 went to 1, negative 1, which would have worked, right? 1, 2 should go to 2, negative 1. Yep. So this point goes here. 3.52 should go to 2, negative 3.5 right here. And 3.51 should go to 1, negative 3.5 right there. Okay. So what is this? This is a this is congruent, meaning that this one is neither, because it's not the same size or shape. Whew, survived another problem. Jeez. All right, 3.3, you write the rules. Here we go. Write a rule that'll transform ABC to A prime, B prime, C prime. All right. So let's start with the coordinates. A is 2, comma 3. B is 5, comma 4. C is 3, 4. B prime is 5, comma 8. C prime is 3, comma 8, and A prime is 2, comma 6. So let's look at the A's. 2, 3 goes to 2, 6, okay? So Y doubled, X stayed the same. 5, 4 goes to 5, 8, so Y again doubled, X stayed the same. 3, 4 goes to 3, 8, so X stays the same, Y doubles. So that one is just X, comma Y, transforms to X the same, 2Y. Are ABC and A prime, B prime, C prime congruent? No. Are they similar? No. Neither? Yes. Explain how you know. Well, if you just look at ACB versus A prime, C prime, B prime, they're not the same shape. Like, see that angle is not the same as that? This is a really sharp angle, not as much here. Really sharp angle, not as, so they're for sure not the same size. This one's bigger than this. And they're also not the same shape. So they are neither. How do you know? Not the same size. Not the same shape. Now, the coordinate rule will tell you why. Because X stayed the same, but Y doubled. So it's a distortion. All right, write a rule that'll translate DEF to D prime, E prime, F prime. This one's so obvious. So let's see. D is negative 2, 1. E is negative 4, 3. F is negative 6, 1. Let's look at D prime. D prime is negative 2, negative 1. E prime is negative 4, negative 3. And F prime is negative 6, negative 1. So let's just look at D. Negative 2, 1 went to negative 2, negative 1. So X stayed the same. Y switched signs. Negative 4, 3 goes to negative 4, negative 3. So X stays the same. Y switches signs. And finally F, negative 6, 1 goes to negative 6, negative 1. So we're going to say X, comma Y moves or transforms to X stays the same, negative Y. Are DEF and D prime, E prime, F prime congruent? Yes, they are congruent. Are they similar? Yes, they're also similar. Similar just says same shape. Neither, absolutely not. Explain how you know. They are congruent because we simply reflect over the x-axis. They are also similar because they're the same shape. So, congruence implies similarity too. All right, that was lesson 3. Yeehaw.